All right, so this is a big one. So we'll, I think we're going to end up spending 2 days on the topic, working with strings and in particular regular expressions. So so a lot of statistical stuff works with numeric data, but a lot of stuff we deal with today deals with text, right? And you have kind of whole segments of statistics dedicated and, you know, machine learning dedicated to kind of working with text data. And a big kind of growing field is natural language processing. There's a minor that you can do, digital humanities minor, and that's going to be a lot of kind of text-based analysis, things like that, right? And so there are a ton of packages that work with or for natural language processing, like a whole lot of stuff. Okay, these are all different packages available in R for natural language processing, and you know, it's just way too much, right? There's also, if you're into it, you can follow this. This will take you to the book Tidy Text Mining, and you can pretty much read the entire book in your browser. Obviously, if you want the print book, you've got to pay for it. But there's kind of this growing trend of like publishing books online and you can just read them in your browser, which is great because there's a whole lot of good stuff out there that you can study if you're into it. We're not we're not going to have the time to kind of really get into natural language processing stuff, but we're going to kind of get a cursory glance at some of the things that are part of it, which, you know, one of it, which is regular expressions. Okay, a whole bunch of other stuff. So there is this just handling strings with R is kind of an entire kind of like a little mini book here. And, you know, there's a section on strings and R for data science. There's text processing on Wikibooks. And then this is just, you know, a help file, a vignette on Stringer, which is what we're going to be looking at. These cheat sheets are handy. The regular expressions cheat sheet is quite handy. And these are websites where you can kind of test regular expressions out, and it will, you know, highlight things in a way that makes them useful. Okay, so let's just go ahead and get started with characters in R. And before I get to that, let me give you your first view quiz answer for today. View quiz answer is the letter D. D as in dog. D as in dog. Okay, so strings and characters, I kind of use these interchangeably. In R, you know, all of this stuff shows up in quotes, and you ask type of, and it will be character, right? And values that are stored as character type, you know, have type of character, and when you print them out, they come out with quote marks around them. So this is one way. So hello world in quotes is type character, and then the output of type of is also type character, right? Because it's in quotes itself. Versus like if the output is just all caps false, then there's no quotes around it, and that's how you know it's typological. Versus if it was all caps false but in quotes, then you'll know it's type character. Okay, you can create character strings by using you know, single or double quotes, and sometimes you want to put quote marks inside quotes, and you can do this by you can use single quotes around R, and it will do that. You know, LaTeX likes to convert the single quotes into kind of these apostrophe looking things, but you know, when you type them in your keyboard, they're straight single quotes. Okay, and it will look like this. And if you you can also do single quotes and then put double quotes in here, and this is, you know, this is the R language, and when it prints out, you get kind of this backslash in front of this, and that what that does is it tells R to escape the quote mark, okay, so that it doesn't close out the quote. Whereas if you tried to say this is quotes an error, this is going to result in an error because this quote sign closes out this quote sign, and then R gets confused about the words that appear here, right? So you can't do that. And so if you wanted to do something like that, you've got to escape the quote by using the backslash. Empty characters are basically quote, quote with nothing in between them. Okay, and so when you say like, I want to create a character vector of length 5, it's going to create 5 empty characters, which will just be open, close quote with no value in between there. Okay, it is the empty character is not the same thing as character 0. Okay, character 0 is a 0 length vector. All right, this a vector with the empty character would be identical to a character 1, right? It's a empty length 1 character vector, but full of empty characters. Okay, so there is a difference between the empty character and character 0. Character 0 just means there's no entries in it, but the vector is character type. Another function that's useful in R is the paste function. Okay, paste is a very important function because it allows you to kind of create and build strings in R. And basically what it does is that you take multiple objects, and what it will do is it'll convert them into character, and then it will paste them or concatenate them together to kind of form strings. And so the basic syntax is you put in the multiple objects in here for the ... The separator is just whatever is going to be used to separate the objects. The default is a single space, okay, a single space. And then collapse will either separate the results or keep them together, okay? And you can also have paste 0. Paste 0 is the same thing as paste, except the default separator is the empty character. Okay, so that's the difference between paste and paste 0, is just paste, the default separator is the space character, and paste 0, the default separator is the empty character. So, so here's a couple examples here. All right, so here I ate some, and then we put in the pie, and then and it was delicious, and then it comes out like this, right? And because we're using the default separator character, it puts a space here, right? Okay, we have 3 objects here: Bears, Beats, Battlestar Galactica. The separator is going to be a comma space, and it creates one single string. Okay, so these are all single strings, or you know, the result is a character vector of length 1, and it puts in the separator here. Okay, here I'm putting I'm pasting the letter H with the vector A, E, and I. Okay, and here our separator is the empty character, and what this will do is it produces a vector of length 3 entries. It does H plus A, H and E, H and I. Okay. Here I'm pasting ABC with the vector 1, 1, 2, 3, and paste is going to combine them element-wise. We have A1, B2, C3. Okay, and this is a length 3 vector. And then over here, I'm specifying collapse. Okay, so here we're going to do A and then 1, 2, 3, and it's going to note that this creates a length 1 vector because I've specified collapse. Okay, so A gets pasted with 1. Okay, there's no separator between A and 1. Okay, A gets recycled and goes with a 2. Okay, and A gets recycled and goes with the 3. Okay, there's no separator between them. But rather than producing a vector of length 3, it collapses the 3 results into one character string and those things are collapsed and connected, joined using the comma space here. Does that make sense? What's happening with the collapse? Okay, because depending on what you put inside the paste, you might get vectors of length 3. Here I put in 3 objects, each were of length 1, so it created a vector of length 1. Okay, 3 objects, each of length 1, creates a vector of length 1. Here I've got an object of length 1, an object of length 3. The h gets recycled, and it produces a vector of length 3. Okay, whereas here there's no collapsing, but here I told it to collapse, and so what might have been a vector of length 3 gets collapsed into a vector of length 1. Okay, so question, is collapse only used when we try to paste vectors? Yeah, so collapse, well, I mean, you can tell it, I think you can tell it to collapse, but it's not going to, like if I specified collapse here, I think it will just not use the collapse character here, right? So let's try this out. So here I'm going to do this, and it does that. And here I'm going to do collapse equals, let's just do a star here. And there's nothing for it to kind of collapse, right? But if I say do this, then it tacks on the 1, and then it collapses it with the star, and then it tacks on the 2. I don't know if you guys can see what I've done here. Okay, so there's a collapsed star, and so because I gave it a vector of length 2, it kind of repeated this, and it does it. Okay, so yeah, collapsing only used when we try to paste vectors, and it will collapse them, right? Okay, few options as far as outputting the strings. Okay, print is just generic printing. Cat will concatenate stuff onto the screen, doesn't return a value, and format will try to print things with special formatting. Okay, so so when you print a string, by default it puts quotes around it, but you can tell it, I don't want to have the quotation marks, and you can say print with quotes equal to false, or you can use the function no quote. Okay, technically the no quote function outputs a no quote class object. Okay, which will continue to sorry about this. 1 second. And so this will kind of retain the no quote formatting for the future if you produce something with a no quote. Whereas cat will just kind of output things onto the screen. Okay, it adds a separator, and if you use one, and it will output the results to the screen. So here x is the character string hello world. Okay, and so here we're going to say hello world, hello universe. They are being separated by a comma space, and they just get output to the screen as well. Okay, printing is different from no quote. In particular, kind of the printed output doesn't have the vector index. There's no bracket 1, whereas over here, because the result, it's not returning an object here. Okay, it's returning, actually it returns a null. Okay, cat doesn't return anything. When we use cat, one thing you can do is you can have it output to a text file. Okay, and so here, instead of having it output onto the screen, okay, like this, you can have it output to a text file, and basically this line will get written into a text file. All right, and so and when you specify a file, there's also an append option, and it will either add it to the end of the file, or it will just overwrite the existing file. All right, and then you can read more in the R documentation. As far as formatting goes, is sometimes you want to output something onto the screen, but you don't want R's kind of default handling of the things, right? So for example, you know, it might output too many digits in pi, and you only want to keep like 3 or 4 digits of pi or something like that. And so, so you can specify some of these things, right? So you can do specify the minimum width of a string. You can specify whether it should trim off extra spaces, okay? Or if there is spacing, then you can kind of use the justify function, and it's going to kind of add on extra spaces so that it kind of fits, you know, in a column, and it will either be right, left, or center justified. When you print out a number, you can specify how many digits to use or things like that, right? Minimum number of digits and things like that, whether to print out in scientific notation or not. And so here's just a few examples. So here I'm going to just do 1 divided by 1 through 5, and we're going to say digits is 2, and so it outputs strings of 1.00, 0.50, 0.33, 0.25, 0.2. Okay. Here you can specify scientific equals true, and then so it outputs everything in scientific notation. And here we can say, you know, hello world, hello universe, width is 10, justify left. And so all of these strings that are outputted have 10 characters in them, but some of them have, you know, a lot more spaces over here versus this one only has, I think, 2 spaces because universe itself has 8 characters. All right, so far so good. Okay, let's talk about just basic string manipulation. So these are base R functions that will manipulate strings, and so, or work with strings. And so you can just ask for the number of characters. You can ask R to convert things to lowercase or to uppercase. You can kind of character translate, which is kind of like uses like a table to translate one character to another, or you can substring or split the string into substrings. Okay, so here we can just ask, here's a vector, hello world, hello universe, how many characters are in each, and it says 5558. We can tell it to make everything lowercase or make everything uppercase, and it looks like we're shouting. Here we can here's hello world, hello universe, and character translation is basically we're just saying take all of the H's and replace it with a Y. Okay, and so we get yellow world, yellow universe, and this is further translation. This kind of does replace all E's with the letter 3, replace all L's with the letter 1, replace I's with an exclamation point, and O's with a 0. Okay. And now you get like some kind of leet speak here. And this still says kind of hello world, hello universe, but written with, you know, whatever. I guess this was cool at one point in our lives. It was never cool. Okay. You can trim off stuff, right? So substring will say, start at the 2nd character and go to the 9th character, right? So hello world, starting at the 2nd character, starts off at E and then ends off at the 9th character, right? 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it ends there. Here we're saying take hello world and split it whenever it sees a space. Okay, and so it returns a list of length 1 because hello world, this allows you to input a vector, but our vector was length 1. So it returns a list of length 1, and the first element in that list is a vector of length 2, hello, followed by world. Okay, you can split it on basically any other character as well. If I split on the O, then I get hell, and then W, space W, and then RLD, right? So it's finding the O's and then kind of splitting the string there. So kind of natural things to use for string split would be spaces, commas, maybe even a tab character. All right. Let me give you your second quiz answer. Second quiz answer is the letter B. The letter B, as in basic. Okay. We've got, all right, so let's talk about Stringer. Stringer is a package, part of the tidyverse, and it handles strings in R, and it makes it really working with strings a lot easier and a lot nicer. Okay, there's other functions in R. There's like gsub and things like that that work with regular expressions, and they work well. But I think Stringer does kind of a much more nice thing, and it works consistently. Okay, and they all kind of deal with missings and zero length characters appropriately, which is really nice. So I highly recommend Stringer. Okay, if you haven't noticed, I'm a fan of the tidyverse. Oh, something happened here. I got to fix this up. Okay, well, this should have appeared on different lines. Okay, but string C will concatenate, similar to paste. String length will return the number of characters, kind of like end characters. String sub will extract substrings, kind of like substring. String duplicate will duplicate characters. String trim will remove leading and trailing white space. String pad will pad a string, and string wrap will take strings and wrap them into paragraphs. And we've already done string trim. Okay, sorry, I got to clean this up here. And you can read more about this here. But let's just work with some of this stuff here. Okay, so string C will automatically remove anything that's null and character 0, right? So here, if I say, let's paste X, which was hello world, null, character 0, and hello universe, and the separator argument is this is what the result will be. Hello world, and it kind of inserts the null and the character 0 here, and hello universe. Whereas string C will remove them and ignore any kind of 0 length characters, and it pastes them together. Okay, so that's kind of a nice thing about string C. And then, and another thing is that the default separator for paste is a space, and default separator for string C is the empty character, empty string. Okay, string length works with factors, whereas regular old end characters does not. So here, if I've got month names, it's not going to work, whereas month names, it'll work. January, February, March has 5, March, April, May has 3 characters, June, July, et cetera, et cetera. So it works with factors. And now we'll get into regular expressions, and I'm so excited. So as far as regular expressions go, it allows us to find patterns in text, you know, and it's a useful thing as far as data validation, data scraping, text parsing, filtering out search results, things like that. Okay, and regular expressions are often called regexes. Okay, and they describe kind of a set of symbols. And this has been established for a long time. And so, you know, you generally, if you learn regular expressions here and you decide, you know, I'm going to do some work in Python and things of that nature, then the regular expressions will work there as well. Okay. And the best way is to just kind of practice and play around. Okay. Things that you can do. You can see if a phone number makes sense, see if a date follows a certain format, see if an email address is in a correct format, right? Test if a password has a certain number of certain number of characters and special characters, and this is always annoying when you're trying to make a new thing. Okay, you can find, if things have multiple spellings, like gray or gray, you can search for both. You can find, any instances of this. You can count the number of times, say the word analysis is immediately preceded by the word data, computer, statistical, or something like that, right? And so these are the functions that come with Stringer. Okay, so there's grep and gsub, and there are certain functions that do exist natively in R, but I'm much more of a fan of the Stringer functions, which are string detect, string locate, extract, match, and split. String detect will return true and false. It will return a logical vector, depending on whether it finds the pattern in the string. Okay. String locate will find an instance of the pattern, the first instance of the pattern, and will return kind of the start and end of that of the pattern, the start and end location of the pattern. String extract will extract the whatever text matches the pattern. String match will pull out anything that's in a capture group, and we'll talk about what capture groups are. Split will split the string into pieces and return a list of vectors here. Okay, and a lot of these will there's also string detect all, string locate all, extract all, match all, split all, and things like that. And those will kind of, rather than matching just the first instance of the matching pattern or whatever text matches the pattern, it's going to find kind of all matches of the pattern. All right, and so, as far as regular expressions go, the most basic is the literal character, right? And so literal characters, you just give it some letter like R, and it's going to try to find the letter R, okay? And it's just going to be matching plain text, right? So all letters and all digits in the English alphabet are considered literal characters, and they will kind of match themselves, right? So here we're going to say locate. So inside the string I love stats, locate this pattern stat. And it comes back and it says, yes, stat starts at the 8th character. 1, 2, 3, 4, 5, 6, 7. This is the 8th. And it ends at the 9th, 10th, 11th character. Okay, and so it returns back 8 and 11 for the start and end of the match. Okay, here it says I love stats. Stats has a capital S. And so what is this going to return? Okay, it's not going to find a match, and it's going to return to NA. Okay, yeah, R starts at 1. Our indices start at 1. And so I is at position 1. The space is 2, L is 3, O is 4, V is 5, E is 6, space is 7, capital S is 8. Okay, here lowercase s is 8. Okay, here we have string locate, and it says I love statistics, so I am a stats major. Okay, and so this is going to find the match for STAT in this sentence or this string. And so it's going to start at 8 and end at 11. Okay. String locate all is going to return a matrix where it says, okay, it's going to find all matches of STAT inside this string. Okay, and it finds it right here, STAT, and then later on it also finds it here, and this is character 30, and character ends at character 33. Okay, and so if you have a whole bunch of matches, you're going to get a big matrix, a row for every time it matched the character. Okay, so those are your literal strings. Okay, and so now we're going to introduce metacharacters. Okay, so anything that's not a literal character, like the STAT, these are all metacharacters. Okay, and this is really where regular expressions become powerful. Okay, and so the metacharacters are all of these things. We've got the dot, the, I don't know what you call this, $, asterisk, plus, question mark, and then all of these braces, curly braces, square braces, backslash, vertical bar, and curved braces, okay, or the parentheses. Okay, so the dot is the wild character. The wild, or the period, is the wild card, okay? And this will just match any character except a new line, okay? And so here I've got a vector, note, not, and nut. And here we're going to just detect these, all right? And it says, ah, yes, I found some variation of n character t, n character t, n character t. It has found it in all 4 locations, so it returns true, 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 true. Okay. Here we're going to see, does it detect no dot? Yeah, so it will match every character except a new line. So it'll match a space. It will, but if you have like paragraphs of text and you have new lines and it's all like one string, but you got like new line characters kind of separating multiple lines of text, it will not match the new line character. Okay, so this will match no character, no, okay, it will not match this one though, because we've got an nu and there's nothing that matches there. So we get true, 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 false, okay? Oh, and this got messed up, okay. Here I've got the 5s, and here I put in 5.00. 5.00, what will it match? It will match, okay, something got messed up here. Okay, so let's go ahead and run this here. Okay, and it matches all of them, indeed, okay? So the 5.00 will match all of these. It matches all of these instances here. Does it have, is there a character for, does it have an N or a T? N or a T? No. This is N, any character followed by T. So N, so it would match N space T, and yeah, N some character T. That's what it's matching. Okay. There is an or operator later, and I don't know if we'll get to it today. So meta characters can't be matched directly as literal characters. If you want to match a literal character, match a meta character in its literal form, you have to escape it with a backslash, okay? However, the backslash itself is a meta character, and so to escape that, you need to get a double backslash, right? So here I've got ABC, opening square bracket, DEF, and I'm asking, does it detect the presence of an opening square bracket? And here it says, no, you've done something bad here, okay? Because it's interpreting this as a meta character. And so if you want to match the literal opening square bracket, you have to give it a backslash, but you've got to escape the backslash itself. So you put in double backslash, opening square bracket, and this will go ABC, and it matches this character, and it says, yes, true, I found that, okay? All right. Okay, and we've got questions about, matching double dots and things like that, and there are ways to do this, right? Okay, so we have this, and we said this matches true. If you want to match the literal dot character and match only 5.00, you have to escape it, and you can do 5/.0, okay? 5/.0, and this will only match this thing, but it won't match any of the others. So we've got that right there. Okay, we can establish character sets. Character sets can be established inside a square bracket, okay? And what this will do is it will match any one of the characters inside the set, okay? So this here represents only one character, okay? And it will say match P and then either A, E, I, O, or U, okay? Any one of those characters, okay? So let's just, so it will match pan because it has an A. It will match pen, this will be true because it's got an E. It will match pin because it's got an I. This will be false. The O is not, the 0 is not one of these characters, so that will not work. The dot here inside the text as far as we're matching, the dot is not one of the characters here, okay? It is not a metacharacter here. The metacharacter, dot metacharacter is only in when you specify a pattern. But as far as this goes, this is all just literal text that it's trying to match, okay? Will it match P-A-U-N? It will not because this has 2 characters, okay? And this square bracket establishes only just 1 character, so it will not match. So even though A and U both appear here, it will not match because these are 2 characters, okay? It won't do this. What about happiness here? Will it match that? Will it detect that? Yes, it will detect PIN here, which will match the P, the I, and the N. Okay, so when I run that, I get a true, 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 false, 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 and a true here. Is that okay? I just kind of want to make sure everyone's okay with the character set.
I have a question.
Yeah, go ahead.
So like so the character set doesn't match only one character, as in what if there's P 2 characters and then N? Is it gonna match?
It will not. There are ways to specify that you will allow for multiples, but
Okay.
let me actually spotlight my own thing here, but then switch back to gallery. Okay, yeah, so here, right as I've written it here, this will only match one instance of any one of these characters, okay? And there is a way to do multiple, okay, but we'll get to that in a moment. Okay, so we got questions. So the dot metacharacter only works when it's in the pattern. Yes, the dot only works when it's part of the pattern as a metacharacter. Here, inside, as far as text you want to match, this will always be a literal dot, okay? Literal dot there. Does the square bracket only work for string detect? It works for any of the regular expressions, okay? The square bracket works for any kind of regular expression, and we'll take a look at what these other regular expressions do. Right now, it's just, does this pattern exist inside the thing, okay? Is that how it is for all numeric? Yeah. Yeah, all the metacharacters, all the metacharacters only take on the metacharacter meaning when it's part of the pattern, not when it's part of the text you're trying to match. So if you wanted to match all of the character letters, all of the capital letters in English, you can establish them using kind of with dashes to kind of create a range, right? So rather than doing A, B, C, D and typing it out like this, you can just do something like all caps A through Z or something like that. Okay, and you can do A through Q, lowercase, capital A through Q. Here, this would be A through Z, lowercase A through Z, capital A through Z, and this will be all kind of 52 lowercase and capital letters that we have. You can also establish ranges for digits, okay? And again, with this is just one instance of the character, Okay, so what can we do to match 3 adjacent digits? So we want to match something like this, 1, 2, 3. Anytime we have 3 digits that are adjacent, maybe like 890. Okay. Yeah. So Ethan's using the thing. So based on what we've shown you so far, you would have to write something like this: 0 through 9 square bracket, 0 through 9 square bracket, 0 through 9 square bracket. Okay. If you wanted to do 3 lowercase letters, you can do A through Z bracket, bracket A through Z, bracket A through Z. Okay. If you do lowercase z through capital Z, will it use the ASCII table? Ooh, I think it will complain to you. I'm not 100% sure, but I think it'll complain if you try to do that, right? Okay. And so this matches this. It doesn't match any of these, and it also matches this. It reads left to right, so it's going to match the 890 here. But yes, later on we'll learn that instead of having to repeat yourself, you can put in a quantifier value to say you want this three of these things. Okay. Sometimes you want to match characters that are not part of a certain set. Okay. And so you can do this using the negative character set, and you put in the that's what it's called, the caret inside the square bracket. Okay, you put the caret inside the square bracket, and this is so if you do this, this will just mean, you know, match a character that is not A, E, I, O, or U. Okay, and so you know, this caret meta character has different meanings depending on where it is. When you put it inside the square bracket, it means not one of these things. Okay, and so for example, here we're going to say match any single character as long as it's not capital A through Z. Okay. So this will return true, true, false. What about these? Okay, these are all true. Okay, so even though the caret is inside here, it is taking its meta character meaning, which means, you know, not like a literal thing. Okay, so it's going to be not the capital letters A through Z. And so this is the only one that returns false. Everything else returns a true. Okay. So the caret, if when you want to say use negation as far as the character sets, the caret needs to be kind of the first character inside the square brackets. Okay, so if you do this, capital A through Z and then a caret, this means it must match any capital letter A through Z or the literal caret. So over here, when the caret is not the first character inside the square brackets, then it takes on its literal meaning. Okay. So this will become true, and this will also become true right here. So this matches this, and it also matches this. What pattern can we use for anything except the literal caret? Yeah, so we can do don't match the literal caret, okay? And I think you can actually just do caret, and it will work as well. But this will be don't match the literal caret, okay? And so this will do everything except the literal caret. All right, you can so the caret is a meta character, and generally when you put them inside character sets, most of the time they are kind of default escaped, except the caret in the first case. So I could have also done I think caret without even having to escape it with the double backslash. Okay, so here if I do this A-E-I-O-U, but then I also put a dot here, this is going to take on the literal dot meaning, okay, rather than a wildcard, right? And so it's going to still return false here, but it's going to return true here, because as far as when the dot is inside a character set, it's going to take on its literal meaning of the dot. And so this is going to be this is going to return true here. Okay. Yeah, so the dot inside the character set now represents the literal dot character. The it says, okay, yeah. Not all meta characters become literal characters when they appear inside a character set. The exceptions are the opening bracket and the closing bracket, and then the dash, the caret when it's at the front or by itself, and then the backslash. Okay, so these are all kinds of meta characters here. Okay, as far as for common character sets, we have common character sets such as any digit. Okay, and you can just do it's slash D, but again, because the slash itself is a meta character, it's going to be /D. But you know, if you go to like other regex sites, they're going to just do /D. So /D is equivalent as the character set 0 through 9. But /D is equivalent to the character set not 0 through 9. Okay, and so the kind of the helpful idea here is basically the lowercase is the thing and the capital is not the thing. Okay, so lowercase d is I want to match digits. Capital D is I don't want to match digits. Lowercase w is I want to match word characters, and capital W is I don't want word characters. Little s is I want space characters, white space characters, and capital S is non-white space characters. Okay, and so word characters are basically things that you could use as far as like naming a file on your computer. Okay, well, that you might use to name. Technically, you can put spaces in your file names and stuff. But basically, it's like I guess if you're trying to like make a username on a website or something, generally they allow only word characters. So it's going to be lowercase a through z, capital A through z, the digits 0 through 9, and the underscore character counts as a word character. Okay, and then non-word character would be anything but those. Okay, and then white space characters are basically anything that's a space, and these are all kind of /n is a new line, R is a carriage return, T is a tab, V is vertical space, F, I forget what F is, but these are basically all kind of like just regular old space characters. Depending on your system, there's a difference between new line and carriage return. It used to be kind of just like, if you imagine the days of the typewriter where you're typing and then you hit return, it rotates the roll. And so you keep hitting return and it rotates the drum roll. And then carriage return, I don't know if you like remember, like it goes over, moves over to the end, and then you have to slide the thing. You go and go and then it moves over, and then you slide it back, right? And carriage return is moving it back, whereas new line is rotating the paper. And that's why there's technically two things. And so like on Windows machines, when you hit enter on your computer, it's technically a new line and a carriage return, which is often thought of as kind of one action together. Okay. Oh yeah. So I'm sorry. So /f is the form feed, N is the new line, R is carriage return, tab, and vertical tab. Okay. And so the /s. So often when you're looking at just white space in a document, the /s is just a useful way to kind of capture all kind of white space characters here. All right. We'll pause here, okay, and then we'll wrap up our slides. We'll wrap up our slides on Friday. We'll finish up our lecture on regular expressions on Friday. So let me give you your last view quiz answer for today. Last view quiz answer is the letter A. A as in apple. A as in apple. Okay. So that'll be it for now. We'll take a look at more regular expression stuff on Friday. It's pretty cool, the things that we can match and find and search here. Okay, that's it. That's all I got for you guys, and we will see you guys on Friday.